So we're in episode 11 of our podcast. We crossed 10, which is huge. I never thought we were going to get here, but here we are. And we have another guest today from a industry that I don't think we've interviewed anybody from games yet.
No, this is going to be really exciting for me because, well, both of us, because we're both really into gaming we want to kind of share the story with people. I reached out to Eric. It was kind of like a cold reach out on Twitter, and we met and we talked a lot about gaming and like game development. So Eric has like a ton of contrasting stories of like how different gaming is from like the standard tech industry, and I found that really fascinating. So I'm really excited to talk to you today, Eric. Do you want to go ahead and just give us your introduction, give us your high-level overview?
Yes, hi. Nice to meet you guys. My name is Eric Martel. I'm currently Director of AI and Machine Learning at Eidos-Montréal. Prior to that, I worked twice at Ubisoft, both in Quebec City and Montreal, where I had the chance to work on Far Cry and Assassin's Creed, maybe 4 or 5 of them. Prior to that, I was working in for a smaller game company that was from France, where we're doing point-and-click adventure games. In the early 2000s, those were a thing. Now it's pretty much disappeared from the landscape. And before that, I was working in an IT company called Nortel Networks, a company that crashed and burned, I believe, in 2001. They used to be a giant, and if I remember well, it's a question of insider trading, and the stock just plummeted.
Wow.
So we actually have, for the first time, I think in the history of the show, the 2 people from Canada outnumber people from the US. Because both Eric and I are in Canada, Courtney is not. This is awesome.
Eric, did you just move? I thought you just moved, Eric. I think.
Yeah, technically I work for a Canadian company, but I currently live in Rochester, Minnesota.
There we go.
Oh, man.
But I don't have a green card, so I am still using my Canadian passport. I'm still on your team.
I was really excited about it. So Eric, tell us more how you broke into the industry. I think that's kind of the question that I want to start with. Like, what led you to games? Why games?
That's a very good question. I always played games since I was a kid, so that's probably 1984 on an old school PC Junior from IBM. Those were the days. I never thought it could be like a career path for me, but at some point I realized that there were game studios in Montreal, which was really close to where I was studying. So I just spent a bit more time researching them, and I found Microids, which was the first company that I was telling you about. And they were, how could I say, they were expanding because they had made a partnership with a Belgian comic book artist called Benoit Sacal, and they were trying to expand their programming team to do some gameplay features for Siberia, which was the first game. And I just happened to know, like, one of my high school friends was friends with a guy working there. So he just put me in contact, and a few weeks later I was working there, which was, yeah, sorry, go ahead.
What time frame was this, just to give us like a frame of reference? I would not have assumed like Montreal would be like a huge or a burgeoning like gaming industry early on, right? Oh, so can you help us like understand that landscape a little bit?
If I remember well, Ubisoft Montreal started in 1997, so it's a while ago. Unfortunately, back then they were doing Playmobil games, so it has nothing to do with what they're doing now. We kept joking around because as a game studio, you often have promotional material lying on the floor. And one of the characters that was everywhere was like a Playmobil little guy from the medieval ages. And I think they were doing games like Alex at the Farm, and like games that you would not expect coming out of Ubisoft Montreal. But back in the day, it was a thing. And so yeah, I joined the industry maybe in 2001. So there were a few players in Montreal. It was mostly Ubisoft. At that point, they must have been like 150 to 200 employees, which is nothing compared to now, where there are probably 3,500 people. Micreds, they were a smaller company. They were basically working on the adventure game and a tennis game knockoff. They couldn't secure the name of the players because the licensing was too expensive. So instead, they had the official name of the stadiums. So you could play like random guy versus random guy at Wimbledon.
That's how I like to play tennis too.
Against
random guys.
But like you could always tell that this guy was Andre Agassi or it was Pete Sampras, but he had like a different name.
They changed the first letters of their names.
Yeah, exactly.
Switch them around.
So I joined the industry maybe in 2001 after working for 2 years, I believe, on adventure games. I wanted something a bit more exciting. So I applied at Ubisoft Montreal, ended up working on Far Cry Instincts, which was the console port of the first Far Cry. Very little people know the game because with the delays we had in production, we ended up shipping, I believe, something like 3 or 4 weeks before the release of the Xbox 360. So a lot of people didn't bother buying games from the previous generation. And it's unfortunate because it was a really cool game for when we made it. It had an in-game editor. You could create your own islands, play multiplayer with friends on those islands. It was pretty advanced for a first Xbox game, but
So it was kind of the back end of that generation of Xbox, right? Like, so the technology had kind of been perfected and figured out, and so it was probably a really top tier production.
Yeah. It was. It's unfortunate because initially we had great ideas, but I'll weigh my words. We were expecting a more optimized game from Crytek, which was the developer of the PC version. Our goal was to port it on consoles, and the PC version was taking something like 1 gigabyte of RAM. On consoles, you have something like 32 megabytes. So it was quite the challenge to make such a big game fit in so little memory. So at the end of the day, we had basically to rewrite the game design, rewrite the levels, so we could actually fit in memory, which added delays to the release. And but thankfully, Ubisoft basically ported the game to the next-gen consoles. So it became, I believe, Far Cry Predator, and there was another one, I think, for the, I was going to say Switch, but back then it was the Wii. Yeah.
Oh, Wii. Wow.
Yeah, so they made a Wii version of Far Cry. I'm not sure if it sold any copies, but yeah. Back in the day, when I was working at Micreds, we basically didn't do that much engineering, so we weren't touching much the code. We were using a visual scripting language where we would create logic blocks that were linked together. So whenever an event would happen, it would trigger a flow of actions to be executed. But as I joined Ubisoft, that's when I started working full-time in C++ and Lua and these other more game-related languages.
And so what did your undergraduate degree look like before you got into the industry? What were you focused on in school? Like, you had this desire, right? You kind of mentioned that you'd always been around games and you thought it would be an interesting career to be in, right? And so, how did that early, formative years look for you?
That's a good question. I'm actually self-taught. I dropped out of college in the late 90s, and that's the fun thing about programming. You can learn on your own with your own time. So I spent quite a lot of time reading about just C++ with the books of Scott Myers and Bjorn Stroustrup. I probably butchered his name, but those were the books I was reading back in the day. And I also spent a lot of time reading about artificial intelligence, which led me to focus a bit more on non-player character behaviors and decision-making in general. So unfortunately, I don't have a bachelor's degree, but I did spend some time learning how to build games on my own.
do you feel like that in any way, shape, or form has affected your career options, like the lack of degree? Because this is something that I feel like I talk to a lot of the folks about the fact that at the end of the day, the degree doesn't truly matter, right? Like, as long as you can learn, as long as you can adapt, and as long as you have that hunger for just doing and building things, that's all that matters.
Yep. Personally, I'll approach it in two directions. I think the biggest hurdle is to pass the HR gatekeepers, like the recruiters that will only look at certain bullet points to see if your CV passes or not. That's the biggest issue when you don't have a degree, because some recruiters are not as technical as others, so they won't understand what you did in your projects, and they'll just look for some key points like, oh, you have a master's degree from this university, therefore you have to be great. For me, it doesn't work that way. And I think, and it's really anecdotal, but most of the programmers that I worked with were self-taught, had this hunger to learn new things. So they would be, I would say, maybe a bit more versatile than other programmers, because they would always be open to learn a new stack, a new technology, a new library, and they didn't need to be, how could I say, to have this structure around them and how they would learn a new topic. So they could just pick up a book or open an SDK and start experimenting with it. So some of these programmers also have a less structure in the way they write code, which can be a downside, but most of them, in my experience, were doers. They would get things done. So personally, I never look at the education section on a resume. I don't care. I've been hiring people for the past, I'd say, 10 years. And to me, there's way too many people that stick to which school you went to or what kind of degree you have. Some of the better programmers I hired had either no degree or a degree in physics or something that was outside of like the typical computer science curriculum. And those people have been amazing programmers.
Right. How did you overcome that hurdle of the filter, if you will? How do you get the visibility and saying, look, I know my stuff, even though this formality is not, I don't check that specific checkbox?
I would say my portfolio kind of helped. Having worked on the first Assassin's Creed kind of was a high point on my CV back in the day, but it's also part of the reason why I left Ubisoft Montreal initially. I know their HR changed quite a lot over the years, but when I left in 2007, I was still being told by HR like, oh, but before Ubisoft, you weren't doing real programming, or it wasn't real game dev because it wasn't, and you get paid less than some of your coworkers because you don't have a degree. So it was kind of frustrating. When I went back to Ubisoft, things had changed, so it wasn't as much of an issue. But it was surprising to me that I was being told those kind of things. And in retrospect, I think it was simply HR people that didn't really know the field or understood what we were doing and how basically recognition went with what you were achieving and not what piece of paper you had. So after having worked on the first Assassin's Creed, I left Ubisoft, and just naming that game, fortunately and unfortunately, opened doors to me. I say unfortunately because I see in the years I've been doing recruitment, I've seen people show up with CVs that say, oh, I worked on Grand Theft Auto. Okay, sure, but what did you do on Grand Theft Auto? It's not because your name is in the credit that you had a big engineering achievement in the game. I've seen people that, I don't know, could have worked on My Little Pony, that worked on the low-level optimization of how the assets are streamed from the disk, that had a much bigger impact on that game, which didn't have a big impact on the game industry. Whereas somebody could have been working on having the credits scroll in the end screen of GTA. That's pretty much trivial. Still, that person has GTA in his CV. So that's something to keep in mind when reviewing resumes.
So how do you personally dig into that with the, you're passing along people through interviews. What's usually your kind of interview screener? How do you approach that?
You mean when I interview people or when typically speaking, we're blessed in 2020 that most people have a GitHub account. So it's always easier to just start looking at the code that the person did and ask them why did it those kind of decisions. Oftentimes I see GitHub accounts that everything is in the first commit, so they don't use GitHub like it should be used. They just work locally until the thing is done and then they push it. So it's always a discussion starter to ask them why did it that way, and then you start digging in like random pieces of code, and sometimes you realize that 90% of the project was what their teacher gave them and they just did little bits and pieces. So it allows you to dig a bit more into what sort of coding experience they have. Obviously now I'm talking more about juniors that are just joining the industry. People that are more senior typically are under NDA, so they cannot disclose what they actually did on the games or how they did it. But still, I typically use open-ended questions like, how would you approach this kind of topic or that kind of problem, just to see their way of thinking. And typically speaking, I hire more for chemistry than for technical skills. I wanna hire someone that I won't mind spending 6 hours with explaining how to do something, more than someone who would do it in 2 hours and then nobody on the team wants to work with because he's like the quote unquote genius asshole that no one wants to be with. So
I think
speaking,
that one of the things in our conversations we've had before, you've talked a lot about, is that the gaming industry by its very nature is extremely stressful anyways. Yes. So in comparison to traditional product design and development, which usually it's on we can push back the schedule or we can adjust our horizon line because we have a luxury, right? In traditional tech. In games, you really don't. It's like there's a launch date, there's a release date that's announced, and they hold you to it.
Yeah.
So, like, I guess, you definitely want to have chemistry with your teammates because there might be times that you're in a crunch mode, right? Yeah. And I would love for you to share that, like, aspect of it. Like, that's just such a stark contrast to, I think, like, what a lot of engineers, like me and Dan, we work on products, web products, quite different from the life cycle of a game.
Yeah. I don't know much other fields, so I might be oversimplifying other fields, but I feel that a lot of typical software, you can come up with a plan and have a good simulation on paper on what the flow will be and how these data structures will interact with one another in order to create the function that you're looking for. For most games, the function that you're looking for is fun, and there's unfortunately no way to approximate fun or know if the pieces will actually be fun once they're connected to one another. So that's why there's unfortunately a lot of crunch in game dev, simply because even if you planned 5 years to develop your games, you never know at which point the pieces will work together in order to make something that's like super fun for players. Sometimes it's within the first 6 months, sometimes it's during the last 6 months, and sometimes you just don't get it. And that's why some games, even though they have big engineering teams, will still come out and have like a 5 on 10 review score. It's also, like you were mentioning, because we're bound to release dates, some game companies don't have the luxury to postpone the release of the game and to make the adjustments to make something fun. And also sometimes it's just too expensive. For example, if you recorded all of your dialogues, all of your motion capture, it's possible that once everything's integrated, you realize that it's not really working, but that's it. That's what you have to work with. When I mentioned that not everybody has the luxury to postpone a release, is whenever you're dealing with a console release, PC and Steam might be a bit different, but on console, whenever you put out a game, it needs to be vetted by the console manufacturer. So it's really similar to what the older guys might have seen with the good old Nintendo cartridges that had the Nintendo seal of approval. This meant that Nintendo played the game and that they were okay with the quality of whatever was on the cartridge. That's probably, in my opinion, what saved the gaming industry in the early 80s, because on previous consoles like Atari and whatever, anybody could release a game, and sometimes the game could crash within 5 or 10 minutes, and there was no quality control. Nintendo, when they added the seal of approval, it meant that their own QA played the game and made sure that it was stable enough to be released to the public. Because remember, back in the day, there was no patches, there was no DLC, so the cartridge you received was the final version of the game, and you could do no adjustments. So yeah, since you need to have that kind of QA, typically speaking, you need to be in queue for example, Sony or Microsoft to allocate some quality control people to play your game. So you can't simply say, oh, well, I'll postpone it 3 weeks and see you guys in 3 weeks later. It doesn't work that way, because Microsoft has a schedule, Sony has a schedule. So typically speaking, it's agreements ahead of time as to when you'll be getting your game tested. And it's possible that your game gets rejected because, for example, you didn't figure out that if the game is played for 7 hours in a row and you lose the network connection at that point, the game crashes. Well, that's a failure of what we call the technical console requirements. So Sony or Microsoft is free to tell us, well, your game's not coming out in that state, you need to patch it. Most studios will deal with the company and be like, all right, well, they will do a day zero patch. So people with a connected console, whenever they buy the game, they'll be able to patch this bug anyway. So this way, it allows the game developer to save time, because printing the Blu-rays and the box and the little pamphlet that comes with it takes some time. So by doing D0 patches, it allows us to still start the process of printing everything while we're still fixing a few bugs. I feel like I rambled. Hopefully I answered your question.
This is fascinating. It's an entirely different process compared to all the other software. Now, something that stood out to me is you called out the fact that you have to plan way in advance for some of the things. For example, the game development, because obviously, you don't ship a game that is as massive as, say, Assassin's Creed or Far Cry or Grand Theft Auto in, a year or 2 years. It usually takes 5-6 years. And I'm a big fan of Grand Theft Auto, and I cannot wait for the 6th one. But even seeing, the fact that, when was it? The San Andreas came out in like 2004, and then the next one was, I want to say like 2010, 11, something like that. Mm-hmm. It takes forever to build something that massive. How do you adjust to things like, obviously technology changes, right? Like if your game takes 6 years to develop, in those 6 years, a lot of things change. Your dev tools change, the toolkits change, the console, maybe there's a next-gen console coming out. How do you adapt?
Yeah, a good game, a good base.
Yeah, like how do you adapt to those kind of, because it's in software, we are always talking about, being agile. You ship fast, you ship. In games, you can't really do that.
I always joked with the expression that what we're doing is sprinter falls. So it's waterfall planning, but made in sprints. So we're trying to be agile while still planning ahead what's going to happen. I don't want to name names of companies, but I think there's a reason why only Rockstar has games as big as GTA. They have a pretty large bank account that allows them to take the time to do whatever they want. And these big developers like Electronic Arts, Ubisoft, Rockstar, they probably all have a red phone linked directly with Sony and Microsoft. So as soon as the next console is getting planned, they get a phone call and they know exactly what's the plan, what sort of GPU we're talking about, what sort of memory capacity. So these companies are able to plan long ahead to be order to hit the next generation of consoles. Whenever you're working seriously with console manufacturers, even years before a console is released, you typically get a mock console. So it's PCs that are spec'd up to be as close as possible to what the console will be. And then you iteratively receive hardware that's closer and closer to what will be in the hand of the gamers. These devices are also super useful because they typically have slightly more memory than what the end user will have, because typically speaking, when you're developing on PC, if you use too much RAM, the OS starts swapping, so copying part of the memory on the hard drive and then do this magic that it doesn't show to the end user other than is PC starting to be super slow. On consoles, there's no way of doing that. So typically speaking, the second you allocate 1 byte over the fixed amount of RAM, the console just crashes. So for that reason, during development, you typically have like hundreds of megabytes, if not the double of the RAM capacity in the console. And basically it allows the developer to have like a big red thing in the screen saying, well, you would have crashed. You can continue working on it, but you would have crashed if it was on retail. That's what we call a dev kit. So developers have what we call a dev kit, which is pretty expensive. I guess I cannot mention numbers because I'm under NDAs, but you could buy a small car with one of those consoles. I think it's simply to make sure that only serious developers can afford them and have them, because at the end of the day, the hardware is still slightly similar to what's in a retail console. And for people who are not aware, whenever you buy a PlayStation or an Xbox, whenever it comes out, the hardware companies always sell it at a loss. The hardware in it is more expensive than the cost you're paying for, simply because they're hoping that people will buy games and offset the price of the hardware with that.
I remember that being a big deal with like the launch of the PS3. You know, I think Sony got basically battered when they initially launched the PS3, like crossing their fingers, hoping they would recoup their cost because it was such an expensive endeavor.
And if I'm not mistaken, that might be the reason why the Dreamcast died, because people realized they could copy games and simply run a copied CD in the Dreamcast. So Sega was selling consoles at a loss and then not selling software. So it didn't take too long for the console to die. And Sega went into big financial trouble back in those days.
Wow. So in this case, from what you described, when you get, to me, the first thing that stood out is like, okay, well, if I'm a dev and I get one of those dev kits before the next gen console comes out, I will make a lot of assumptions about the tech stack and the ability and say, oh, I have 4 gigs of RAM. And when the console comes out, it's actually now 2, right? How do you not over-index, I guess, on the perf specs of what you have early on? Because you can make certain design decisions and design compromises based on the hardware that you have, only to realize later that, oh, wait a second, it's completely different.
Fortunately, we never had those bad surprises. It's not something that I've seen in the past, other than an anecdote that I have from the first Assassin's Creed. When we finally received the final version of the game, we might have been the first game to fully utilize all the cores on the Xbox 360. And we didn't realize that we were really pushing the console to its limit. The game was running at 30 frames per second, so we were we're in the green, so everything's fine. But then one of our technical directors brought the copy home, and that's probably like 5 days before we start duplicating the discs, the guy brings the disc home and starts playing. Within a few seconds, the sound keeps cutting, and he's like, what's going on? And then the next day, he, since you're from Canada, you might know that store. He went to Future Shop, which was bought by Best Buy, and he went to the audio video section of Future Shop with a copy of Assassin's Creed, and he was like, well, can I try our game on as much hardware as possible? And the guys working there were like super excited because they were happy to see the game before release. And we realized, I think it was something like 50% of the amplifiers would stop the audio and restart a few seconds later. So fortunately, Ubisoft had a really good relationship with Microsoft, and they helped us right away identify the problem. We were using a bit too much the core where the audio processing was being done. And back in the day, if I remember well, the XDK was sending the wrong signal to the amplifiers. So some of them would like start looking for a new signal instead of just waiting the next few milliseconds to receive more audio. So we almost had like a pretty massive bug for the game simply because all of our amplifiers at the studio were the same. We had bought like a few and were using them for testing, and those ones were fine, except for when the technical director brought it home. So we dodged a bullet there, and ever since, I think most studios and even first parties like Microsoft and Sony start diversifying what kind of hardware they use around the console, from TVs to amplifiers, just to make sure that the game would run on a wide spectrum of consoles. So thankfully, we never had issues with specs that we were aiming for, but I did run into issues where a game that I hadn't foreseen was kind of released before our game. When I was working on Thief 4, it's like a game where you're trying to steal things in the Victorian era, and the goal is to not be detected and to play as stealthy as possible. I would say maybe a year before our release, that was a 5-year development plan, and maybe a year before we released, a game called Dishonored came out, and Dishonored is amazing, and it completely overshadowed what we were doing. And in the end, I still think that Thief should have been Dishonored, but they were better than us and they came out before us. So I think we deserve, quote unquote, the flack that we got for Thief. It could have been a better game. And I wish we had done Dishonored.
So when you're looking at developing for console, right, you're a studio and you're looking at, I'm developing console, you know, a lot of the time you see like a release for the PC version of the game alongside, or it might be a little bit delayed. Yeah. You know, you've just described developing on a piece of hardware given to you maybe by Microsoft or given to you by Sony that's like a faux machine, right? It's a PC machine. Yeah. Help me understand a little bit, like, you know, obviously if you're developing this thing for cross systems, you'd want to do the same thing for diversifying your hardware, right? Because PCs are so, like, there's so many different variables with a PC, right? Yeah. Your end user on a PC could be running like the craziest rig ever with everything maxed out, or somebody with like super low spec. Mm-hmm. And if you're, I guess, what's the strategy if you're a studio that's like, I want to have my game on all platforms, not just, you know, like look at Overwatch, right? I think that's a great game to talk about because it's like everywhere. It's on every platform.
My experience is mostly with the console studios. So typically speaking, most games are developed on a Windows machine. So each game engine supports to some extent running on PC because people are testing what they're doing on the PC. That being said, most games are meant to be used with controllers. So the developer itself works on the controls using, for example, an Xbox controller or a PlayStation controller. And basically you make sure that playability is feasible on the dev spec of the hardware, but any serious developer will always run it on console to make sure that the frames per second is really what you're hoping for, and that the experience is really what you're hoping for. So I would say the PC version is often like the little brother that trails behind. It's rarely the focus of a developer to be like, let's nail the PC version and then we'll port it on console. Typically speaking, it's easier to port it on PC because you can establish what's your minimal spec and then support any specs higher than that.
So develop for that lowest common denominator and then go from there. You know,
exactly.
and I imagine, we're talking a generation ago, but like, I imagine like developing for Nintendo systems has to be particularly interesting because they always seem to have some sort of quirky difference in the way that their, system is interacted with or presented to the user, right? You look at the Wii U that had like this separate, basically, it was like the prototype of the Switch with like an actual hard console, and you didn't see as much support from third party, I don't feel like, for that console. And I wonder if that like also was part of the reason, like, it was low spec anyways, in comparison to the 360 and the PS4, but I think Nintendo kind of sometimes is always in that like different area, right? They're just different enough that it might make it a little hard to develop as a third party.
I will preface this by saying this is my personal opinion, not my employer's opinion, but I feel like Nintendo has so many strong first-party games that it makes it really hard as a third-party developer to get into their ecosystem without getting completely destroyed by a Zelda or a Mario game or a Metroid. It's really hard to compete with the games they have and the marketing budget that they have for their own games. And since you were mentioning, they always have like a little hardware twist that most other consoles don't have. So it becomes more expensive to make a version of your game for a console that might not be your core audience, where you'll most likely get overshadowed by first-party games. So that's why a lot of developers pulled out of developing for Nintendo, because it was a money sink.
Yeah.
Would you have the same thing for other platforms as well? Because if I think like Microsoft has Halo, right? But I guess on Xbox you have a much more diverse set of games where it's like not everybody's playing Halo.
Yeah, and Halo is iconic, but you can still have some other shooters that compete in the same genre. Like Call of Duty is doing really, really good, and it's rare that you'll have someone say, oh, I don't want to play this game because it's not Halo. Whereas action platforming games get kind of compared to Mario, and it's really hard to have like a Banjo-Kazooie or like some other title that's in the same genre, like a cartoonish action platformer, without getting the direct comparison to Mario, or you're a fantastic medieval game, therefore you're competing against Zelda. Obviously, there's still some genres that Nintendo don't redo themselves, but I was about to say, I guess there's like racing, but then you have Mario Kart. I was going to say fighting, but then you have Super Smash. So it's really hard to compete in the Nintendo ecosystem against Nintendo. That being said, I'm sure that Square Enix has a lot of great titles that are running on Nintendo consoles, but I just left the Nintendo ecosystem after the GameCube, personally, as a consumer.
I think you also had mentioned that there's this whole, behind the scenes for developer support and developer ecosystem, making it easy to develop for the platforms. And in this generation, you've already seen a shift in the way that Xbox, Microsoft and Sony have geared, right? Like they both kind of tried to step up their game when it comes to serving developers, the people who are going to actually be building for their systems. Can you talk a little bit about that?
Well, again, personally, I never worked with Nintendo, but I know that Sony and Microsoft are basically the two companies that we're working most with. I was slightly disappointed by Microsoft when the Xbox One came out, because for the Xbox 360, the software stack that was integrated in Windows Explorer, integrated in Visual Studio, like everything was working out of the box, and it was a great experience. In our opinion, it was because Microsoft was a software company, whereas Sony was a hardware company. So it would make sense that Sony's integration was a bit more clunky, whereas the one from Microsoft would be butter smooth. But when the PS4 and Xbox One came out, there was a shift there. So Sony hired some new developers to make sure that the experience of developing with their console was top notch. And honestly, I'm not sure what happened with Xbox, but a lot of tools required a lot of manual interactions, and it was just not a great experience. I cannot talk about next consoles, but there's it's definitely, if the tools are right, it's definitely easier to work with the consoles, because most of our games imply a lot of tooling around them. So you have the content creators that will create the levels, create the characters, the animations, all of that. But typically speaking, all of those end up on a repository, be it on Perforce or GitHub, or, well, GitLabs or whatever. And then you have build machines that grab all of the data, that will cook the data. So optimize the data structures, make sure that everything's packed in like a big file that's easy to read at runtime. And all of these processes typically at the end will talk to a game console to, for example, deploy a build to a console and make sure that in the morning all the game testers have the latest and freshest version of the build. Obviously, when you have a good and clean ecosystem, it makes it easier to do all of those steps. But if everything needs to be manual, and then you have your testers come in the morning, click on a batch file, that's start copying I don't know, 30 gigabyte file on their console, it's not as straightforward.
What does the documentation? So Den and I are both from like the developer documentation world. So we like heavily invested in it, right? I come from Stack Overflow. Den has worked on Microsoft Docs for a long time. So I'm intrigued to know, like, you know, there's kind of this like I said, behind the scenes developer ecosystem that happens for gaming. Who does like all that developer documentation, right? Like for Sony, like you're developing for Sony. Sony obviously has to have people, you know, they have a team doing that. Like, what does that look like? Yeah. Or is it like kind of just a community of, you know, developers working at different studios sharing information? Like, how much gets shared, I guess, between studios? Is it a closely guarded secret, or is it like a burgeoning community where you all try to work together?
That's a good question. I would preface it by saying, in my opinion, there's not enough sharing in the world of game dev, and a lot of studios still, maybe 20 to 25 years ago, being a master of the hardware, being like the most clever programmer, made you have a game that would stand out. That's why John Carmack is so well known. When Quake came out, it was incredible what Quake was compared to other games at that time. I think a lot of game development execs are still in that mindset that any piece of code is like the secret sauce and sets your studio apart from other studios. In my opinion, in the past maybe 10 to 15 years, it became more a creative advantage. Like, do you have the right developers to make a cool concept come out and be fun? It's less about the algorithms and how the code is structured, more what's the storyline, what's the experience for a player.
Yeah, and I think that this is interesting because this starts to get into like AI, right? And this is your specialty, which is like AI is that mix of like creativity and making sure that it's an experience that would be really rich to the user and make sense and feel real, versus, like I said, if you have a great AI team, you're going to have a great game. And I think
yes and no. How could I say? A lot of difficulty with AI for the common people right now. AI is, well, they don't know it, but it's typically deep learning, or, for example, the the server code on Facebook that identify faces of your friends whenever you're posting a picture, or a clever recommendation algorithm on YouTube. That's what AI is for the common people. What we typically do in game dev, I jokingly call it artificial stupidity. The goal is to make the characters credible, but dumb enough that the player's always better than them. So you're trying to create opportunities.
So it doesn't feel cheap, like the game is trying to beat you all the time and just...
Yeah, well, for example, most shooters, there's specific code that whenever an NPC will shoot at you, they miss the first bullet, and we often try to have the first bullet pass in front of the camera so that you see the trail, you hear the bullet, and you're like, oh, I'm so good that I managed to avoid the first bullet. And then there's like mathematic formula to make sure that like you don't die from a bullet spray. It's making it, it's figuring out ways to make the player the star of the show.
Did you guys ever watch that cartoon Reboot?
Yeah.
That's what it reminds me of, right? The game drops down, and then they have to be like, well, we have to lose the game for the player. Like we could beat them, but we're not going to. We have to let them win.
Although I was gonna say, if you play Gears of War 5 on hard, like whatever the hardest mode is, whatever they did with their AI, that thing shoots you in like the first second when you get out of behind the counter. I had to like so many frustrating nights of like, why can't I get past this?
Yeah, but that's a challenge you mentioned on hard. Whenever you're developing a game and you have multiple difficulty settings, it implies testing the game multiple times for each of those settings. That's why a lot of studios, unfortunately, will simply resort to having multipliers. So the harder it is, the more hit points or the more damage the enemies do. But it's quite a challenge. On Thief, we had for a challenge, if I remember well, difficulties like you could not be seen, or so it was twists on the game mode, which I found more interesting than just making the NPCs detect you at like 75% of the timer. They're like, oh, you're there, I'll come see you. So yeah. But yeah, a lot of studios don't want to share code. They barely want to share ideas. So it's always interesting when developers are allowed to participate to what we call the GDC, the Game Developers Conference, where we get to share our ideas and algorithms. To be honest, most of the talks there talk about ideas and how to achieve them, and not specific implementations of here's how I actually did the code that's running. But it's still very helpful for the developers. So yeah, like you were asking initially, both Microsoft and Sony have technical writers that make sure that the documentation is up to date. Technically speaking, a lot of studios will have an engine code. So if you've heard about the Unreal Engine, Unity, or most studios have their own engine, if it's not one of those, that they will use internally to create the game code on top of that basically core of functionality. And the game engine will be the one responsible to be basically compiled for each of the platform. And that's where the interface with like the specific SDKs, for example, for Microsoft or Sony. So you can abstract, for example, reading and writing from the disk at the engine level. So a gameplay feature could ask for a sound file that's on the disk, and you don't need to worry about, well, how's the sound file fetched, etc. So it's only like very specialized programmers that will read the doc from Microsoft and be like, oh, here's how I use the API to ask for an asynchronous read on a file on disk.
I think the interesting part here too is, and this is something that I've encountered with machine learning specifically and any kind of tutorials, and I think that's probably, I would hypothesize, that makes sharing a little harder, is because it requires you to have that context. It requires you to have the knowledge behind the scenes, right? It's very hard to teach somebody, deep learning in a week-long course of saying, oh, here's the 5-step tutorial on how you can be an expert in deep learning, or how you can use the algorithm for detecting, collisions. I feel like there's a lot of complexity and I wonder if there is an extent to which people are just kind of saying, you know what, this is too hard to explain. It works. I wrote it. It's there, and whoever needs it can reuse it. And
yep, I agree with you. In the challenge, I gave a few presentations at the AI Summit at the GDC, and my challenge was, let's say there's 400 or 500 people in the room. How do I write a presentation that will resonate with most of them? When you have game designers, you have level designers that are interested in AI, so they want to learn more, but they're definitely not like this programmer that wants to see meta programming with templates and C++ and all of that. So it's really hard producing content for such a niche field, because game dev is big, but it's not that big if you compare it to writing J2EE applications, where like you would have millions of programmers that would be interested in what you're doing. Game dev is still hyper specialized.
It's it's like a really niche group, and then it's also like it seems very secretive.
Yeah.
Right. So you also don't want to like reveal your employer's secrets.
Yeah.
And I mean even the complexity of explaining those secrets, say if you wanted to. It's still like oftentimes looking at resources online for both like game dev and machine learning. It's always, that the joke about how do you learn to draw an owl? And there's this, start with like 2 circles and then draw the rest of the owl. It's like, okay, this is not exactly teaching me how to do this. I don't get it. Like you show me like the first starting steps, but then I'm missing this whole rich context of the rest of the project.
Yep, definitely. And to talk about like giving out some studio secrets, most of the presentations I did or the articles I've written had to be signed off by top execs. My first article, I had to have the contract signed by Yves Guillemot, the CEO of Ubisoft. So I felt I still was a nobody back then. I had just started making games and I wanted to write an article, and they made me, like the lawyers made me ask Yves Guillemot to sign my piece of paper, and I was like, why can't you guys do it? Anyway, it was fun times.
That's fantastic, because I can imagine the scrutiny when you're like, it's just a blog post for my own blog. It's like, no, the CEO has to approve. It's like, oh god, now I have to refactor the entire thing.
Yeah, and there's a lot of PR too that needs to validate the message. We did a GDC talk about some of the tech that we did in Assassin's Creed Unity, and it was maybe 5 months after the release of AC Unity, and unfortunately you guys might be aware Unity was not the most well-received games of the Assassin's Creed franchise, mostly because of graphic artifacts, which I will get back to. It's funny but not funny at the same time. We wanted to make to explain part of the tech that we developed for encounters that you have whenever you're walking the city, like someone getting mugged or whatever. And we obviously had some debug display to draw lines of who can see what and which areas on the ground are valid to spawn these encounters. And PR initially didn't want us to publish any of this at GDC because there was debug draws added on top, so it didn't look polished enough to show what Unity could be. But we were like, it's a developers conference, they all use that. It's not for the end user. We're just conveying information, trying to teach people. At the end they allowed us to do it, but it was quite the challenge. And Courtney, you were mentioning before the wide range of hardware that's available for PC gamers. If I remember well, not the thing that killed AC Unity, but that really damaged the image the game had, was this good old picture of Arnaud, the main character, that was just 2 eyes floating with, I think, the tongue and no face. That screenshot comes from PC Gamer, and if I remember well, the thing is, if you were running with old NVIDIA drivers, when you started the game would be like, wait, your drivers are too old, click here to install the new drivers. But you can always like kill that process and be like, no, I still want to play the game. So it was someone playing on PC with outdated drivers. When they reached that point in the game, for whatever reason, the memory layout wasn't good and the face would not draw. And it's really hard for a developer to shield yourself against those kind of situations. So we were working on Assassin's Creed Syndicate, which was the follow-up. Well, not really follow-up, but the next title after. And we started having, if I remember well, it was a filter in Jira, our bug tracking software, where it was like a potential YouTube or something. So any bug that could end up leaked on YouTube as like a graphic issue was already was moved on the top of the stack as like a super high priority, because we wanted to avoid those kind of situations. But at the end of the day, you cannot control what a PC gamer does with his machine.
I should not complain about having to debug browser bugs now.
I love the concept of a YouTube-worthy bug. I want to put this in every single dev team that I'm working on now, because like, is this YouTube-worthy? Are people going to film this and say, what the hell did you do? So, Eric, I have a question for you to kind of wrap up our conversation. And kind of, I want to learn, Courtney called out earlier the fact that in the game industry, oftentimes there's crunch mode, there's very intense periods of work.
Yep.
How do you balance that in your life and make sure that you're not burning out, right? That you're constantly energized about things that you're doing. You have that passion for games. It's clearly visible, and from our conversation today. But how do you keep it sustainable?
I would say most developers are now much more mature and take crunch time more seriously. My worst experiences must have been, let's say, between 2005 and 2007, 2008. That's when I would say the average person in the industry was quite young. A lot of them were single, no kids. Now in 2020, a lot of people have aged. They have a significant other, oftentimes kids. So they don't want to be at the studio until midnight. They want to spend some quality time with their spouse and kids. And I don't know if you remember, I think it's in 2006, a letter called EA Spouse. It made the rounds in the media. It was basically the wife of an electronic arts developer explaining online how many hours her husband was putting in and how little he was paid for it. And it made waves in the industry. So a lot of companies started to take the matter more seriously. And back in the day, a lot of people were working overtime for zero, how could I say? We weren't paid for the overtime, but some studios were still accounting how many hours you put in, like on a side spreadsheet. So it wasn't in the accounting, but it was still kept somewhere. So at the end of the day, if the game was very profitable, then there was like a bonus system for how much you put in, you would get some money out of it. Most studios realized that this was really not compatible with family lifestyle. So I would say what I've seen in the past few years, both at Ubisoft Quebec and at Eidos-Montréal, is that whenever you want to do overtime, you need to have the approval of your lead. So your lead needs to be like, okay, you want to work more, I'll let you do it, but you will get like 1 day vacation for every day that you put in. And it's not like never ending. Back in the day when I was working on the first Assassin's Creed, I was probably working on average 80 to 100 hour weeks, which was not sustainable. But back in the day, I was young and dumb, so I was fine with it. Now, my lead would tell me, no, you're not doing this. You won't be able to sustain, and I need you until the end of the production. So let's evaluate what's needed for the next milestone. What can we cut? And then, okay, I'll agree for you to spend 2 weeks with 20 hours of overtime that you can spread over the weekend and night days. And at the end of the milestone, I'll give you a week off. So it's much more sustainable. It's bursts of overtime, but it's definitely not the type of crunch that we used to see back in the day. Obviously, I'm sure there's still some studios that crunch like crazy, especially indie studios where they need to basically publish in order to get some payments or a way to feed their family. But most game developers that are publishers at the same time have enough money in the bank to be more responsible with the way they tackle overtime. So I know all the studios in Montreal, like all the big ones that I know people working at, Ubisoft, Eidos, EA, BioWare, Warner. I think they're all like super responsible with overtime, and they don't overtax their employees, because at the end of the day, I've rarely been really optimal past 40 hours. And oftentimes you see at the end of the project, the quality of code just going down because people don't think straight. They're tired. They're
just not performing optimally. Exactly.
And it's been proven like from early experiments that most people past 40 hours, they're not as performant. Yeah.
Well, this has been fascinating. I personally learned a lot from you, Eric. Thank you so much for sitting down with Courtney and I and discussing all this. I think just like, with a lot of interesting conversation, I think we need to have a repeat because there's so many more questions that we have in the future for you. So hopefully we did not scare you off.
Anytime. I'll be happy to answer your questions.
Yeah, this is fantastic. Thank you.
Where can people find you at, Eric, if they want to just kind of see what you're sharing and what you're doing in the world?
That's a very good question. Right now, since I'm doing R&D at Eidos-Montréal, there's not much of what we do that's getting published, but I'm working on that to have some sort of blog platform on the Eidos website where we can show our white papers, because my team right now is comprised of mostly people doing deep learning and really, really interesting things that we're starting to publish. But anybody that wants to reach out personally, they're probably better off going on LinkedIn. That's where I'm most active. I lurk a lot on Twitter, but I never post unless it's really rare that I'll post on Twitter. And I got rid of Facebook. I'm really happy of that. I don't need that. And LinkedIn
What's your favorite game right now? What have you been playing?
I'm not playing anymore because I got burnt out of playing games, but I do watch a lot. I would say on Twitch, I still watch a lot of League of Legends. I'm also a fan of Rocket League. I think a lot of it comes from the fact that I grew up wanting to do esports, like mid-90s, late 90s. I was playing a lot of StarCraft, and I quickly realized that my hopes were higher than my skill set would allow me to get to. So that's why I get so frustrated playing Rocket League. Like, I wish I was better. I wish I could do aerial hits and whatnot, and I always fail. So I ended up just watching talented people.
It's fun to watch people that are pros do it, though.
Yeah, exactly.
No matter how much I play Rocket League, I still suck.
It can still be fun, like without doing the crazy stuff, but it's when you compare yourself, that's when you get disappointed. And unfortunately, with Twitch, it's so easy to see. I think I mentioned it.
Better.
Yeah, I think I mentioned it to Courtney last time. I got Dark Souls 3, and I tried playing that game for a few hours. And then I opened a YouTube video, and I think the guy within 15 minutes was further than I was after, 5-6 hours. So I just stopped playing the game. I'm getting too old to do rolls, and yeah.
It's so enjoyable to watch. I mean, people do all kinds of crazy stuff, and you see, the Mario speedruns and people doing all that crazy stuff where it's like totally fascinating. You're like, yeah, I know I would never be capable of doing that. But this is awesome to see somebody putting in the time and the effort and the kind of the talent and actually putting that together.
And the most impressive, I know we're getting out of time, but the most impressive is seeing speedruns that use bugs in the game code.
Yes.
For example,
yeah.
Yes.
I've seen someone.
Games done quick is amazing.
Yeah, I've seen someone play God of War where they went into a fountain to trigger the swimming animation, and then they just flew out of the fountain, and they were going in between worlds, just swimming, and it was quite impressive. It's really hard for us to test everything.
I always wonder, like the Games Done Quick guys, when they're doing those for charity, I'm like, how in the hell did somebody figure out to roll backwards 3 times into a wall, then jump twice, and then you get clipped in and you end up at the very end of Mario? Right? Like,
none of those are just kind of like, oh, you know what? I stumbled across this like the green tube and I figured out that it's transparent. No, somebody's like, if you go to this second while you're crouching, also pressing the B button and the left trigger, then like, how many iterations do you have to go through until you figure that out? Like, unless you're reverse engineering that code, I don't get it.
And even then, a lot of it has to do with timing. So reverse engineering the code would still be really, really hard because you need to reverse engineer how the memory layout will look at this very specific moment. Yeah, it's super impressive.
Yeah, and how do you test or find like a clipping through a level? I don't know.
We do have some QA technicians that spend their days walking into walls and trying to see if they can clip through. It's a commendable job. I would not do it. It must be really, really hard. But we're also looking into using technologies like reinforcement learning to have agents learn how to do those clipping tests and run through the level and try to clip through everything, so that it's done more procedurally and can be done overnight. Yeah.
See, there's a lot of topics we still need to cover, so we need another hour. So
whenever you want.
We have to have you in another episode of the podcast.
Sounds good.
Well,
thank you so much, Eric.
Yeah, thank you for being here.
Thank you, guys. It was super fun.